Hello and welcome to Algebra 2. This is lesson 2.5, using linear models. Learning about math is great, but we actually have to use this math out there in the real world. And a lot of times we are able to model data after sometimes lines, maybe quadratics, maybe cubics, but our data kind of fits into a pattern, if you will, right? So down here we have 5 scatter plots, and there's this thing called a correlation. And a correlation is the strength of the relationship between your y value and the x value. The stronger the relationship, the closer those data points, those dots on the graph, come to a line. The further away from a line, like if you look at the middle one there, if you were to draw, like if you put a rubber band around all of those dots, it'd be almost a circle. And we would say that there's really no correlation between the x value and the y value. So the stronger the correlation, the closer those dots become a line. The weaker the correlation, the closer those dots just resemble a big circle. So a lot of times we get our data in the form of a table like we do here. And just looking at a table doesn't really give us an idea of how the data is portrayed. So we want to, a lot of times, want to make a scatter plot, which means you have to make an x and y axis. The x would be the independent variable, the thing that affects the outcome. So in this case, the temperature would be affecting the electricity bill, because the hotter it is, the more that your air conditioner is going to run, or the colder it is, the more that your heat's going to run. So we plot these points and we look to see if there's any kind of correlation. Is there some sort of association between the temperatures and the electricity bill? And then in Algebra 1, you should have learned about a line of best fit, which means that we would try and figure out a line that we could draw like that gets all of those dots as close to the line as we can. Okay, you'll learn more about that in AP Statistics if you ever take it. But the line of best fit is also a prediction model. So with this, now if I said, hey, I know that next month is going to average 90 degrees here in Florida, we can predict what our electricity bill would be. And looking at these dots, we would say this is a very strong correlation. Those dots are pretty much in a pretty good straight line, okay? So back in Algebra 1, you called this line here a line of best fit. But moving forward, we're going to call it a regression line. We use a lot of regression lines next year in AP Pre-Calc, and you'll definitely learn about regression lines again if you take AP Statistics, okay? But it's just a line that goes through, as best it can, the middle of all of your data, okay? It's like the average idea, if you want to think about it that way, because it's in the middle, okay? So if this regression model is a line, it should make sense that we have a slope idea, right? And our correlation is just a number, and it's a number between -1 and +1. The closer we are to 1, the stronger that correlation is, the stronger that association between the x value and the y value are. And we do have to worry about the sign, because a negative slope would mean it goes downhill. So if you look at this one, that line is going downhill. And even here, like, it's definitely not a line. It's not a great correlation number, but you can tell that it trends downhill. And you look at this one, it's hard to tell. And I'm going to be honest, all of these guys in this area are really hard to tell which way they're going. So we usually deal with more along the lines of these guys over here, where we can definitely see that, oh, that's a positive correlation or that's a negative correlation. And, you know, it's good to know how strong it is, but it's not all that important. So how do we find this line of best fit? Well, really the only way to do it is with technology. So if you have a graphing calculator like the TI-84 that you're going to need if you're going to move on in math and take AP classes, it's real easy. We make a couple of lists, and then there's a button that we can push, and it'll calculate everything we need. You can also use Desmos. and I'll try and show you how to use Desmos here in a little bit. So what we did here, our list one was the number of years after 1997, because it says in the problem, let 1997 be year 0. So 1998 would be 1 for your X value. And then it just put your cost of milk in the second list. And then you run the calculation, and it does all of the heavy lifting for you. And we come up with this A right here is our slope, because we're using y equals ax plus b. And I'm gonna let you on a hint. I don't want to use that one. There's another one on our calculator that says y equals b plus ax. It's the exact same thing, just written in a different order. But because that's what we use in AP stats, that's what I want to start using here. But they both mean the same thing. A is your slope and B is your y-intercept, right? So I could write my thing, y equals 0.093x plus 2.526. I like going out 3 or 4 decimals. Here in Algebra 2, they don't always do that, but since you're in my class, let's go to at least 3 decimals, okay? All right, so B is asking, using our linear model, how much would we expect to pay for a gallon of whole milk in 2020, right? So how many years after 1997 is that? And I believe that's 23. So we're going to take our formula. They rounded it a little bit different, but that's okay. And I put 23 in for it. Now, I do have a problem using, because I teach the AP Stats class, 2020, using that date in the model that we created is a little bit, we shouldn't be using this date because our data stopped in way before 2020. So we're way outside of our data set with this date. And as far as Algebra 2 goes, it's not that big a deal. But as an AP Stats teacher, we have a problem with this because we don't know that our data is going to stay the way it is. And when we look at the answer here, you should understand, because look what my answer is. That's saying that back in 2020, milk should have cost $4.60 a gallon. And it doesn't even cost that much now, which is, 6 years later. That's why might this be wrong? Well, at some point, there could be other factors that are affecting the price, whether it goes up or goes down. So just because it seemed kind of linear in that small period of 1997 to whatever, doesn't mean that it stayed linear all the way through 2020 and now 2026. Just a little bit of foreshadowing, that's called extrapolation. When you're trying to predict a value that's way outside of your data set, that's called extrapolation, and we are always cautioned to not do that. Okay, that's the end of this lesson.